Hello class, welcome back. This week we're going to start looking at branching statements and a new data type, a Boolean data type. As we talked about that earlier, Boolean data type is a very specific primitive data type. It holds only two values, true and false. And the branching statement is one of the few types of statements that we have in Java that we can use to make decisions and optionally execute some code or not, depending on the value of an expression. So where does this all come into play? Well, the Boolean variable can be either true or false, and that is what we need to use to make a decision on something. Either the item we're going to evaluate, the variable that we're going to evaluate, will be either true or false when we compare it to either another variable or a value or something else. So we're going to take a look at that in a little more detail, and in the next video we'll look at some other items related to branching and a different kind of statement, a switch statement, which will allow us to do multiple branches simultaneously, or nearly simultaneously at least. Okay, so what is a branch? So a branch statement is exactly what it says. You can either go down one path or another depending on a condition. So far, all the code we've seen so far is executed sequentially, one line after another. There's no choice, there's no changes, everything goes in the same order every time, which has its functionality and it's valuable in coding, but it's also much more interesting if you can make decisions and do things or not do things depending on what the variable is. And we can get a little complex with our expressions by combining multiple variables and multiple expressions together to get some really complex logic. And we'll see some examples of that in a few minutes. Okay, so let's look to see what a Boolean variable is before we can actually start using it in our code. A Boolean variable is a variable type that has exactly two values, true or false. This is what we're going to be using when we make our decisions in our if statements to either optionally execute a piece of code or not. And combining multiple Boolean variables, we can get really complex with some of those logical operators, the and or, and the not, that we'll look at. We're going to also introduce the curly brackets, which we've already kind of seen a little bit from the lab templates, but we're going to explain what they are. And essentially, the curly brackets indicate a code block, a group of statements that get executed as if they were one statement. Meaning that once you enter a code block, you keep executing the code in that code block until you get to the end curly bracket. Using the curly brackets helps us organize our code and make it much more readable and understandable. And we'll see some examples of that in a few minutes. Now we have to look at what are we going to use for comparisons. Well, we have some things we can compare. We have the ability to compare for equality with two equal signs. Note that the two equal signs is a comparison operator, where a single equal sign is an assignment operator. So there's a little bit difference there. So the short answer is use the double equal sign when you're doing comparisons and only when you're doing comparisons. You have the exclamation point equal for inequality, checking to see if something is not equal. Then you have your greater than, and less or equal to. Then you have your less than and your less than or equal to. So we talked about what a Boolean variable is. We've talked about logical operators. Now how can we start combining these? Well, a Boolean expression is an expression that evaluates either true or false. Variables and values are compared with logical and relational operators. So here's some examples. In the first bullet, x equals y will yield a value of true if x is equal to y. It doesn't assign the value of y to x. It only compares the two values to see if they're equal. Similarly, x is less than y will give you a true if the value of x is less than, but not equal to, the value of y. There is no assignment, there is only comparison. And then you have some other oddball ones where you have 1 equals 1 or 1 equals 0. And this is just a way of making something be always true or always false. But of course, you could always use the keyword of true or false to represent that. In addition to the comparison operators, or the relational operators, we have logical operators, and, or, and not, represented by the two ampersand signs, the two vertical pipe signs, or the exclamation point. These are used to compare two Boolean variables or Boolean expressions to make a more complex expression. So, for example, if A and B are Boolean variables, this expression here would be true only if A and B are both true. Here's another example, the next bullet, not A. That would be true if A itself is false. In the third bullet, we're combining two different operators and two different Boolean expressions. We're comparing the score if it's greater than or equal to 90, and then we're comparing it to, we're combining that with score less than or equal to 100. So only if both of those two conditional expressions, the score greater than or equal to 90 and score less than or equal to 100 are true, would this expression be true. And finally, where we have more of an algebraic term that is similar to the bullet above, you cannot chain operators together like this. You can only compare two items at a time, hence the Boolean, hence the two operators, the true or false. So if you wanted to do something like this, you would have to break it up using an AND statement or an OR statement. So again, Boolean variables and Boolean expressions are built up comparing two things, no more, no less. Well, strike that no less comment because you can have the single operator here with the not. Okay, let's look at some high-level flowcharts of what an if statement looks like before we start writing out some examples. So this is the most basic of if statements. This is a single condition where if the condition itself is true, then we're going to execute the code statements in that code block, which is wrapped in the curly braces. If the condition is false, nothing happens. So again, if the condition itself is true, we follow down the true path into the statements, we execute whatever those statements are, and we come back. If the condition is false, we follow the code straight through, and we do not execute the code statements. Now, something to note, you do not put semicolons after the curly brackets. They do not need them. In our next example, this is the if-then-else version, the else version, where if the condition is true, which is the same as we had before, we execute these statements. If the condition is not true, the condition is false, we execute these other statements. At no point can you execute statements 1 and statements 2 at the same time. The condition will be either true or false. And again, there's no semicolon after the parentheses, or after the curly bracket. And you could see you can get a little more complex and really build this out. Here's a more complex with multiple conditions. You have 2 different conditions and 3 sets of statements. And again, you cannot execute any more than one group of statements at any time the way this is written. So let's write some examples and try to demonstrate some of these different operations for us and see what they look like. So I'm going to jump over to our test area, and I've already reset it, so we have a nice new area to play in. Let's start with an integer variable. We're going to declare an integer variable, and we'll call it score because we kind of saw that in the slideshow a little bit. And we'll use our scanner, and we will do a scanner equals new scanner system.in, and we will prompt the user enter your test score. So we're going to run a little program that will simulate a test score and an evaluation. Let's start with an equality test. if, we'll start with an if statement. So the if statement is followed by a condition, and it's followed by two parentheses. You wrap the condition in parentheses like such. And if you see, let's say if score equals, notice the two equal signs, 100, then we can print perfect score. And we'll close out the curly brackets on the if statement, and we're good to go. So let's give it a try and see if it runs. Oh, it has not been initialized. So this is an error. The variable scope might not have been initialized for score, so we'll just set score equal to 0. Always a good idea to initialize your variables when you first use them and create them. So there we go, now it runs. So let's enter our score. Let's say we got 100 on our lab. Good job. Oh, I forgot to put in the read statement. Let's put that in next. SCNR score equals SCNR.nextInt. Would be helpful if I actually read the value after I asked for it. Let's try that again. So we'll enter our test score, 100, and it prints perfect score. Great. If I run it again with something that's not 100, 99, so close, it didn't print anything. So this is the example of testing for equality. Testing for equality. And we can put a second if statement in here. Let's test for inequality. Score is not equal to 100. If the score is not equal to 100, let's print out better study more. And that will print out for any value we enter that's not 100. Let's try that. On 100, we know gives us perfect score. 99 gives us better study more. Now we can do this with two separate if statements. Or we can combine them into a single if statement with an else. So let's try that and see what that looks like. And we'll use the same exact values. If the score is equal to 100, system.out.println, perfect score. And again, now we'll put in our else. And now system.out.println, better study more. So you see, we don't need this extra piece of logic here. We don't need to compare if it's not equal to 100. So either it is equal to 100, which we will do our top piece, or if it's not equal to 100, that's our else. So it's either equal to 100 or it's not. So we can combine those into one statement. You put a comment in here for us. And I'm going to temporarily comment out these other two lines so we don't have all that extra output. Okay, so I just commented out those first two examples. So if I run it now and I enter 100, perfect score, very good. Run it again with a 98, better study more. So same output, and it's a little bit easier to read, a little less code, and one less decision we have to make because we already know the answer. So maybe now that we have the equal and the not equal, let's take a look at a greater than. or less than. If score greater than 90, right? Or we can even make it greater than or equal to 90. And we can print your grade is an A. So if we run it, sure enough, if my test score is 100, perfect score, your grade is an A. If I run it again and I put 95, I'm expecting to see from this statement, better study more, followed by your grade is an A. And there it is. Now if I run it again, and this time my score is 85, it simply points better study more. It meets this criteria here, but does not meet this criteria. Okay, so we have equality, we have inequality, we have relational, we have the greater than or less than. Let's look into combining some of these into a more complex statement. Let's create another variable, and we'll call it attempt, set it to 0. And we'll ask again some new information, system.out.println, how many attempts did you take your test for your lab? And attempt will be equal to scanner.nextInt. So the premise here is we're going to enter two values, the test score and the number of attempts. Now maybe if your score is a 90 and you took it on your second attempt, we want to print good job or something along those lines. So let's build a statement. Score greater than or equal to 90. And we use the and signs, the ampersands. Attempt less than or equal to 2. System.out.println, and we'll print the message saying, well, only one retry, something along those lines, just to demonstrate the end portion of it. So let's run that. Oops, I made a mistake. What is it not liking? So let's take a look at the error trace and see what we have here. It's complaining about line 41, illegal start of expression. So we need to put everything in parentheses. So let's put parentheses here and parentheses here around the entire if statement, and let it fix that problem. So enter our test score. We'll give ourselves a test score of 95 and the first attempt. And here it is, only one retry. So here is how we're combining things. So the thing to note with the AND statement, or the AND operator, is both of these must be true for this whole statement to be true. If I run it again, and my score is still a 95, but I took 4 attempts, notice it did not print this because this was true, but this was false. So that's the thing about AND statements. If any one of those conditionals is false, the entire statement is false. And the reverse is true. If we were using OR statements, if only one of those OR statements is true, all of them are true, because OR is a OR inclusive function. You only need one true to make all the ORs true, but you only need one false to make all the ANDs false. And I think that's shown in our book. We'll take a look at that in a second. So that actually brings up the subject of called short circuit evaluation. So when this statement is evaluated, it evaluates it left to right. So if it determines that this is true, it will need to examine this statement here to see if this is true, to determine if it's going to execute this statement. And when I say it, I mean the Java compiler. Similarly, if the score is less than 90, this is false. So the interpreter now decides that if this is false and it's an AND statement, this entire statement is false and does not need to be evaluated. So we do not need to evaluate this statement if this first one is false. Let's write one for the OR statement now, and we'll make it similar. If score less than 60, or the two pipes, attempt greater than 3, then we'll do a system.out.println, please contact the professor. So the idea here is if you have gotten a score less than 60, or you've taken 3 attempts to complete this, you may need a little extra help. So let's run that, and we'll put in a score of, first run we'll put in a score of 55, and the attempts will be 0. So 55 here would be true. Attempt 0 would not be greater than 3. This would be false. So this would be a true on the left and a false on the right. And true or false becomes true. Let's try it out. Oh, I forgot the semicolon. Okay, fix that. Run. So we'll put in our score of 55 and 0 attempts. Better study more. Please contact a professor. If I run it again, and let's say I got 100, but took me 5 attempts or 6 attempts, again, please contact a professor. One of these was true, so it executed the statement. So there is a good little chart in our textbook in the short circuit evaluation chapter. Where is that? Here it is, 3.16. And it just pretty much reiterates what I just said about it only evaluates as much as it needs to make the decision. And there is a little chart here which gives you some indication of what is calculated and what is not. So good little reference. Keep an eye on this chart. Might prove handy in the future when you're trying to build complex instructions. Okay, let's go back to the table of contents for a minute. We're coming up on the time limit for the video. We discussed a lot of the features that are common in these first 7 sections, along with the order of evaluation, which we've discussed in prior chapters. Next video we'll cover switch statements, and we'll talk about some character operations and some string operations, and the floating point comparison, which is a little trickier because floating point is not stored like an integer. A floating point is stored as an estimation. So we'll look at that in a little more detail in another video, but this should get you going. You have only 2 labs this week because there's a lot of reading material, a lot of practice material. So give it a try. And if you get stuck, give me a call or set up a meeting or send me an email. I'd be happy to help. Okay, that's it for now, and I will talk to you all in the next one.